This is gonna blow your mind. Welcome to our channel. If you love uncovering the mysteries of the past, make sure to subscribe, like and share this video so you never miss out on our latest discoveries. 5,000 years ago, before iron blades, before electricity, before machines that scream and spark, human beings were already solving a problem that still humbles modern engineers. They were drilling precise, perfectly circular holes through granite, basalt and diorite, stones so hard that even today we struggle to shape them without powered tools and diamond abrasives. These holes were not accidents. They were not decorative guesses. They were controlled, repeatable and intentional, and the proof is still carved into the stone of ancient Egypt. Temple floors, sarcophagi, statues, quarry blocks abandoned mid-work. The mystery has never been whether this happened. The mystery is how a civilization with no steel, no electricity and no engines managed to do it so well, and why that method mattered so deeply to their survival. If you're watching Warcraft Survival because you care about how humans endure harsh environments, adapt to limits and build systems that last, this story matters. And if you value serious evidence-based history without the nonsense, take a moment right now to like the video. Share it with someone who appreciates real history, leave a comment with your thoughts, and subscribe to the channel. That support keeps this kind of research alive. Now, let's get into the facts. At the heart of Egyptian stone drilling was not brute force, but control. The core tool was a hollow copper tube rotated against stone using human power. Sometimes this rotation came from a bow drill, other times from a vertical shaft weighted with stone to maintain pressure. Copper alone cannot cut granite. That is not a flaw in the system. It is the foundation of it. The Egyptians understood that the copper tube was not the cutting edge. It was the guide. The actual cutting was done by abrasive particles, primarily quartz sand, introduced between the rotating tube and the stone surface. Quartz is significantly harder than copper and close to granite on the hardness scale. As the tube rotated, the sand ground the stone away, while the copper maintained alignment and shape. Structure and cutting medium were separated, allowing precise control without cracking the stone. This approach reveals a level of material understanding that is often underestimated. Instead of trying to overpower stone and risk fractures, the Egyptians abraded it slowly and deliberately. This minimized internal stress and allowed clean, uniform results. Archaeological drill cores recovered from sites like Giza show spiral striations along their length, clear evidence of steady rotation and consistent downward pressure. These marks are not random. They indicate trained operators using a standardized technique. You do not get this level of repeatability through trial and error. You get it through specialization and institutional knowledge. Stone drilling in ancient Egypt was not an isolated craft. It was part of a wider production system that included quarrying, transport, abrasive sourcing, copper refinement and tool maintenance. Quartz sand was not just scooped from the nearest riverbank. It was deliberately selected for grain size and hardness, and sometimes transported long distances. copper tubes were repeatedly reshaped and annealed as they wore down. Drill teams worked together, managing rotation speed, pressure, and the steady flow of abrasive. This was industrial practice by ancient standards, not improvisation by primitive labourers. Modern viewers often judge ancient technology by speed, comparing it unfairly to powered machinery. That comparison misses the entire point. Egyptian stonework prioritized accuracy, repeatability, and longevity. The holes produced by hollow drilling were used for dowels, fittings, ritual components, and structural alignment. Errors could not be corrected once the stone was cut. Precision mattered more than speed. The uniform holes created by this method allowed massive stone blocks to be joined securely, helping monuments survive thousands of years of thermal expansion, seismic activity, and erosion. Environmental constraints shaped these technological choices. Egypt lacked abundant timber, iron, and fuel. These limitations forced efficiency instead of excess. Abrasive drilling required minimal energy and relied on materials that were naturally available. Human muscle was not replaced by machines, it was amplified through mechanical advantage. The result was a system perfectly adapted to the Nile Valley's resources and labour structure. Its long lifespan is not evidence of stagnation. It is evidence of refinement. Modern experimental archaeology has confirmed again and again that this method works exactly as the physical evidence suggests. Using copper tubes, quartz sand, and controlled rotation, granite can be drilled predictably and accurately. No lost technologies are required, no unknown energies. What stands out is the Egyptians' empirical understanding of hardness, wear, and process control, all developed through observation and preserved across generations. This technology mattered because stone mattered. Monumental architecture was the backbone of Egyptian political and religious authority. In a land shaped by seasonal flooding and environmental uncertainty, stone projected permanence. The ability to shape it reliably reinforced the idea that Egypt itself was eternal. The drill was not just a tool, it was a statement of order, control, and continuity. Technology, belief, and governance were, inseparable. The Egyptian drill reminds us that true technological sophistication is not about complexity. It's really about fit. A solution that works within its environment, respects its constraints, and, endures across generations, is more advanced than one that burns resources for speed alone. Ancient Egyptian engineers did not overpower stone. They understood it, and that understanding built a civilization that even now still speaks to us through stone. If you want more deep, evidence-based history like this, make sure you're subscribed to Warcraft Survival. Share this video with someone who values real historical insight, and leave a comment below. Your support helps keep serious history alive.